Hi folks, welcome back to Fish Tank, the show where investors will judge cool new hydro inventions. Brought to you by our team, 20,000 Legos Under the Sea. I'm your host Jacob, and today's investors are Lord Business. You may know him from the Lego movie released recently, and he's learned a lot since then, and is now trying to make the world a better place.
I'm not trying to rule the world anymore.
In hopeful, coming to us from Spain, she's been spending her time looking for inventions to help people.
Hola!
And Emperor Einstein. He's a brainy guy who knows a lot about everything. When he asks you a question, you'd better know the answer.
I don't know it. It's not my phone.
And here to present their inventions are Mr. Whiteboard, Frank, John Paul, and Matt. Gentlemen, what do you have for us today?
Hello there. We are very excited to be here today. What would you say if I told you that there's a clean, renewable source of energy that we're not using that's right above our heads?
Are you talking about the sun? Because I know all about solar energy.
No, it's not the sun. It's a little lower.
Ha, I thought you know everything.
I know it's wind.
Not exactly. It has to do with water. We pay design for
Water tower power.
Yeah, if you think about it, there's a man-made waterfall in every water tower. Look, every time someone pours a glass of water or flushes water, water runs down out of the water tower.
What does this have to do with energy?
We can use the water running down to the water tower to create electricity. All we need to do is add a generator.
We like inventions that solve problems. What problem does this solve?
This is more of an opportunity than a problem. Almost every urban community has at least one water tower. Most have many more, but no one is using them to create power.
I should have thought of this first. How did you come up with this idea?
We have to start by simply make electricity using the water coming to people's homes. Our expert, Mr. Obiela, the water superintendent, County Utilities, encouraged us to think bigger.
The more water in the water tower, the more energy we can produce. The average water tower holds 1 million gallons of water or more, and is around 15 meters tall. That's a lot of potential power.
How does it work?
First, our water tower design has two pipes leading up into the tanks to the one. One where the water goes up and one where it goes down.
We'll put a turbine in the downflow pipe. The water is always in motion, so the generator will always be producing power.
How much power are we talking about?
Generators this size won't be able to power a city. The idea is to use the power produced to lower the energy needs for the utility. But when more and more water towers producing their own power, they can have a big effect.
Each water tower is different. The amount of electricity we produce depends on the size of the water tower, type of generator we use, and other things. One size of the Collins water tower has 500,000 gallons. About 130 feet high will make 12 to 13 kilowatts per hour.
Interesting. But this sounds expensive. How much would it cost?
Our idea is to use this design in new water towers or in water towers that need to be repaired or refurbished. For example, Kakonda's latest water tower cost just over $1 million. Mr. Moore, an engineer at Total Energy Systems, helped us figure out that our design would cost $75,000 to $80,000 the first time, but the cost would reduce as we get better installation.
How does this help people?
Takes energy to pump water into the water tower. The utility has to pay for that power.
The Kakana utility spends about $150,000 per year on electricity. Using our design, they could generate up to $11,000. That's a savings about 7%. Or they can use the power to heat up the water tower or run its systems, making it a zero-sum energy user.
We could also adapt this idea to work for skyscrapers too.
I think you guys are onto something. What do you think?
Tune in after the break to see what our investors decide. But the real question is, what do you think? We shared our idea with employees at Kakana Utilities, engineers from Total Energy Systems, Chris Shaw, director of Appleton's Water Utilities, and the Rubber Duckies, a rookie FLL team. Thank you for listening to our presentation. Or would you like to see our proof of concept demonstration?
Okay.
I would also like someone to lift up your board here so I can see the bottom.
Oh yeah, I need that.
Okay, thank you.
Alright, proof of concept here, yeah.
So this is our water tower, and we are going to be using an air compressor to represent the water tower because we are not allowed to use water. So the water would run down through the water tower whenever a valve would be open, such as a toilet being flushed or a faucet being turned on.
produce electricity that we then generated. The electricity would then go to heating the water tower or helping produce electricity for the city.
So you went a little off-field, which I appreciate. How did you come up with the idea of using water for power?
Well, one of our first ideas, well, we kind of wanted to head in the power direction for like hydroelectricity and stuff like that. So our original idea was to create tiny little generators to go into the pipes that go into people's homes. But Kevin Obiala, the expert that we talked to, which switched us to water towers, told us that if we put those little generators in the tiny little pipes, it would decrease the pressure enough so that when you turned on the faucet or something, it wouldn't go at all. So we put it in the water tower instead, which produces more power with less expense because you don't have to have as many generators and stuff. So
Yeah.
That's
And-
a bigger difference.
Yeah, and the only flaw about our design is that in the water towers, there's either one pipe going up and down or two pipes leading up and down. So our flaw is that you would have to have a two-pipe system to go on the downflow pipe because ours wouldn't work with one system.
Yes, and we would have to put a check valve and make sure that the water's not coming back through and like turning the generators the wrong way or making it hard for the pumps to work.
Well, when you think about it, it isn't really that much of a cost difference because the Kakana water tower, which is a relatively small water tower, costs $1 million to build. But the small generator would only cost $75,000 to $80,000, and that would just be the first time. And that's just a little fraction of what the actual water tower would cost.
And what was your cost savings that you said was $11,000?
Yeah, $11,000.
7%.
Yeah.
Did you figure out how long that would take to pay itself off?
It depends on how much the original installation cost, because it's just a simple math problem. Like 11,000 times, like how many years?
Yeah, like,
Yes, and depends on how much people are using the water tower and the type of generator and the efficiency of the generator.
yeah. Also, like we said in the presentation, it also depends on like how much water is the water tower holding and stuff like that. But yeah,
Yeah, the taller it is and the more water rushing down, the more power it's going to produce.
and it's like, and with the amount of people in the city, it's always like flowing, especially in the mornings when everybody's getting ready or when they're getting home from work.
I like your idea, it sounds very straightforward. Do you have any idea why no one's doing it right now?
Well, there's this company called Lucid. They're doing an idea similar. They're doing it from reservoirs
Like
instead.
man-made.
Sewer pipe.
Yeah, so basically, they're doing it in the tunnel that brings the water from the reservoirs to us, and so they're putting a generator there. But
Yeah, but the difference is that they're doing non-man-made reservoirs when we're doing man-made reservoirs.
And the cool thing is that after we presented the idea to Kevin Obiala, he actually told us that they were going to be talking about something a little similar in a conference meeting the next day.
He liked our idea so much that he wanted to bring it up to the other people that he was telling.
And who else did you present it to?
We presented to engineers from Total Energy Systems. We presented an idea again to the Rubber Duckies. They're in other FLL team, but they're not here today.
Yeah, and then also Chris Shaw, director at Appleton's Utilities, which is a big thing.